I'm Steve Claude, an 85-year-old patient of JangoBio. Thank you, guys. I'm the other co-founder of 32 Auctions, which is a platform for hosting and managing silent auction fundraisers.
Hi, I'm Theo Howard, and I make a lot of artwork and install it online, and I'm working on a couple fitness apps.
Hi, I'm Jiwon Paik. I'm Chief Marketing Officer at JangoBio.
Craig Atwood, founder of JangoBio. Sounds like we've collected a new recruit.
I'm Chandra Miller-Feenan. I'm the Executive Director of Starting Block Madison. We're the entrepreneurial hub that is occupying the second, third, and fourth floor of the Spark building. We opened up in June, and if anyone is interested in seeing Starting Block, we have tours after this that you're available to join us for. Thanks.
I'm Keith Fuller. I'm the founder of All About EX, which is a service for startups when they get serious about people.
My name is James Kademan. I have Calls on Call. It's a shared receptionist service for small businesses. I have to get a shout out to 32 Auctions. They helped us with a fundraiser for my kids' nursery school. And we raised 50% more money with the silent auction than we did with just a normal table silent auction with their app. So, super cool.
Good morning, I'm Heather Ewing. I'm with White Box Commercial Property Group. We specialize in retail brokerage, both for ownership and also tenants. So I say it's all the fun, interesting things like restaurants, fast casuals, fitness, hard goods, and the like.
My name is Travis Human. I own Stray Cat Bicycles here in Madison, which is a consumer direct bike company. But I'm looking for new opportunities.
I'm Laurel Lake. I run Parabo Press. It's a photo printing company, direct to consumer. They order on our website. We ship to their house. If you want to know more about Parabo, I'm on James's podcast this week. Authentic Business Adventures. Look it up.
They have one.
Yeah.
I'm Derek Kevler. I'm with Town News, and Town News is a technology company that works with media companies for websites, OTT, mobile, and video.
I'm Chuck Serra, a patent attorney at DeWitt Law Firm.
I'm Chris with Haldeman Homey. We build out laboratory space, storage space. The other side of the company does athletic space if you want to put a basketball court somewhere. But I'm on the lab side, so that's what we do.
My name is Paul Temple. I'm too short to play basketball. And I'm an attorney at Alpha Tech Council here in Madison.
I'm Xiuming Du. I'm with Brain Excel. It's a stem cell company in the brain disease area.
Mike Hendrickson, I'm project manager at Brain Cell. We're a biotech over in the research department.
I'm Alan Dines. I'm with Twist Partners. We're a small UWLP-based investment firm, mostly all around Madison right now, but we're fully invested, so I'm just interested in what's going on, so we'll do our next fund. Well, that's my deal.
And Alex, I'm with the Wisconsin Economic Development Corporation.
My name is Marty Stotts, and I'm a small business accountant.
I'm Dan Anderson. I'm with the accounting firm of Baker Tilly.
I'm Brian Dennis. I'm the director of the Cybersecurity Center for Small Business, a new effort out of the University of Wisconsin Whitewater.
I'm DP Knudten. My company name is Collaborator Creative because I collaborate creatively with a wide variety of people, companies, individuals on creating, crafting, and discovering their completely true, completely you brand and all that stuff. And this is my lovely daughter, Julia, since it's Force Your Daughter to Come to 1 Million Cups Day.
We're actually going to make that an official theme once a month, please.
All right, so with that, we are happy to turn things over to our presenter today, Bill from JangoBio.
Thank you. Bill Cole, JangoBio. I hope that this is a presentation that you're going to find unique to other presentations you may have gone to in the past here, because I believe this is going to impact everybody in the room. Aging, therapy we're developing to address the symptoms of aging and other maladies that come about with aging. We've got a unique approach in technology. We're very, very eager to present this to you and get your thoughts on it. JangoBio started as a concept about 2015 from our founder, Dr. Atwood here, and essentially looking at the impact of hormones on aging You know, we all know that they help in our development, but they also play a role in our development, if we could call it that. We're going to tell you a novel approach that we think can reverse impacts. We've got about 10 employees right now. I say 12 active advisors because there's a number of us that are unpaid workers in the organization that are dedicated to the cause of getting this into the marketplace. Personally, I got involved, and I'm not paid, I got involved as an investor because I wanted this therapy for myself. Everyone else can have the money, I just want the therapy. We've got 2 facilities, one in the University Research Park, one new lab development facility on Fitchburg off Yarmouth, and we're hoping to expand those soon. We're growing rapidly. We'll talk about that a little bit. What we're going to talk about today is just a light education on, you know, what roles hormones play in our life cycle, including the aging process, how we can permanently restore our hormone balance, basically enabling our bodies to put hormones back where they were when we were at our peak youthful levels. And then we'll talk a little bit about how you might want to participate in this if you'd like to. But we do have a much more in-depth, larger presentation that's going to be happening on the 20th of March over in the Research Park area. And if anybody's interested in getting an invitation to that, where we'll talk about this much more in depth, both the science, the application, where we are, and the finance aspect of it. Come and see one of us 3 here after the meeting. We'll get you on that list. So here we go. What's the big deal with hormones? I think everybody understands hormones are important, right? We hear about them all the time. We need hormone supplements. Hormone deficiencies are the cause of this, or extra hormones can make you big. The real challenge for the hormone replacement therapy has been, how do you rebalance all the hormones? We can take an estrogen patch, a testosterone supplement, something of that nature, but that's one of maybe 70 some odd hormones. All those hormones play a role. So why are we treating just one, and how do we know how much to give one person versus another person anyway? What we're going to do is restore all of those hormones. So the impact of hormones, I think most of us recognize, they're responsible for us growing and reaching puberty, and most importantly, being at our peak reproductive age. That's what evolution has been all about, right? Making sure that we can reproduce our replacements. I'm feeling those replacements coming up behind me now, and I'm not ready to go. But if you think about what happens in nature with animals, different animals live different lengths of time, right? We've been able to correlate how long an animal lives when it starts experiencing the maladies of aging directly with the decline or dysregulation of hormones. We can get into that in more detail on the 20th. But just suffice to say that there's a direct correlation where our hormones are in our life and when we start to experience the impacts of aging, including age-related diseases. Many people, including myself, before we got engaged on this, thought that, well, we just wear out. You know, we go through so many cycles, cell divisions, free radicals, radiation, too many Diet Cokes, whatever it might be, and you start destroying yourself and you wear out. But if you think about other animals, in this example, the salmon, they are perfectly healthy until they go and breed, they reproduce. The thing that happens after they reproduce, their hormones crash. The impact of those hormones crashing, they age rapidly. They age within a week or two what takes us decades to do. And if you think about that further with animals that we are all familiar with, dogs, cats, rats, mice, they all have different life cycles. So if it's free radicals that are impacting them and wearing them out, why are they wearing out so quickly? If it's the number of cell divisions that are wearing them out, why are they dying after a year and a half? A year and a half rat dying of cancer, Alzheimer's, or heart disease, all the things that we die of, hasn't had any more cell divisions, hasn't drank any more Diet Cokes, well, except for some experiments, but they haven't done anything more than we've done, yet we're living a lot longer. The correlation between all of those animals is when have they reached their peak reproduction age, then they start to decline. And if you look what happens after your peak reproduction age, the hormones are declining. Some are going up, some are going down because they're interacting. That's what we're addressing. How do we stem that interaction. I mentioned earlier that there are over 70 hormones in a human being, right? The ones that we hear about mostly are testosterone and estrogen, and those are good indicators of where we are with our entire hormone balance. We don't have to measure all of them, so we'll use these throughout this presentation as an indication too. But I want to draw your attention to when two leading indicators in men and women, the testosterone and estrogen, start to decline. Obviously women quickly at menopause, but men start to decline after the age 30. Women catch up with us quickly after menopause, and then we both share the same decline. Another reason that women live longer too, because they start declining in their hormones later than men. Again, come to the 20th and we'll talk about that more. But look at this graph here of when, we don't even need to see this graph. We all know from personal experience when friends and family and other people that we know have started experiencing those age-related diseases. And this is just a few of them, right? But how many people in this room know people over 50 that have started experiencing things like this? Direct correlation with the hormones. We'll talk about that more detail at the other presentation, but part of our therapy is based on known science that's been around for many decades, and that is that if you can share the constituents of young blood into an older animal or person, now there's some companies that are trying to market this, you've probably seen it lampooned on some television shows, of putting young blood in old people, it really does have a beneficial effect. People haven't known why. What is it in the young blood that's helping these old animals rejuvenate? When they do this with rats, for example, or mice, which has been done for many decades, the older animal benefits from that younger blood in that they start restoring their hair, they lose weight, they get their metabolism back, they get their cognitive abilities back. All just sharing that young blood. Now, it's not very practical to just, put somebody young on our back and share the bloodstream, but it is semi-practical to get their plasma, and there's companies like in New York that are charging like $8,000 a therapy to get young blood plasma injected into you on a regular basis. Not very practical for the masses, and we'll talk about the ethics some other time. But there's solid evidence for that working. What's available today, and the market that we would be going after directly in humans, we're going to talk about animals in a moment, is the hormone supplements, again, that all of us in this room are familiar with. Testosterone patches, estrogen, side effects, cancer, other related side effects that are listed here. Part of that's because we're giving ourselves a synthetic hormone. I always liken it to, we're pumping up one tire on a 18-wheel semi-trailer that they're all going flat, but we're pumping up one. It helps, but it's not the solution. And how much air is right for Josh and how much is for me, the doctor's guess. Is this making you feel better? Is this making you feel better? We're going to change that so that your body is just generating enough hormones for you, wherever you are in your age, wherever you are in your activity cycle, and eliminate the pharmacological aspect of hormone therapy eventually. Do that with humans, we're doing that with animals first. So what are we doing? We're actually utilizing stem cell technology. Many of us here in Madison know that this is the home of stem cell technology and growing. We're part of that. Unlike some other stem cell technologies out there, we're taking a different approach. We're not just trying to regenerate tissue randomly by injecting you with some of your own stem cells. We've got another approach where we're actually creating the tissues that we want before we put those tissues back in our subject. So we're creating, in this case, the hormone-producing tissues from your cells, putting them back into your body, and then letting your body take over, regenerating its own hormones back at its useful level. Not too much, not too little, just what's right for you, because your body's regulating it. Pretty safe, because they're your cells. We're not doing anything with somebody else's cells or pharmacological drug. These are your cells. So this is the part that's similar to other stem cell technologies out there, where they take your adipose tissue, your fat, your bone marrow, whatever, cycle it up, re-inject it into a knee or an elbow and hope for the best. Sometimes it works, sometimes it doesn't. There's no real objective way to know if it's working or not. With our therapy, we know, because when we regenerate the hormone-producing tissues, we see those hormone levels go up. So we know if it's working. We don't have to say, Josh, are you feeling better? Are you looking better? We know. And we'll do that as part of the service of this business. And again, more detail later. But regenerating, we've discovered certain tissues has an impact on all the other hormone-producing tissues in your body. So we don't have to regenerate all of them. Not all of them degrade. It's mostly just the ones that are associated with our sex hormones, gonads, ovaries. Real basic what we're doing. I mean, you guys have probably been to other seminars where you've seen how the technology works. So we're not doing too much different than anybody else is, other than what we do in this phase and this phase to make the tissues unique for your body. We'll answer some questions on that later. So right now, we're finishing up an array of experiments with our rat models, and we are about to go into beagles, and I'll explain why in a moment. But what we're seeing in the lab and expected results should be demonstrating both the efficacy and the safety of this procedure, increasing of the targeted hormones. You know, we're not looking at all of them right now, we're just looking at those targets, and then we'll do panels. And then the observable health benefits. So we look for cognitive improvement, we measure body mass, eventually we'll be measuring bone mass, obvious things like, are they getting their hair back if they're getting old? Where we are in our current business status is we started off with a $364,000 grant from the NIH. We gave this concept to the NIH, we asked for $250,000. They said, we'll see your 250 and we'll give you 364. And we went, okay, I like this. But we also learned in the process that they only grant about 14% of what's applied for at this phase. They have a team of scientists and doctors that review what you're doing and say, okay, this has got merit or it doesn't have merit. They thought it had merit. They gave us a check. We started running with it. We started initial experiments, started getting some data. We went to Joey's group and got WEDIC certification so that we could go out and get some angel private investment. And to date, we are on a $2 million raise, and we've raised $1 million of that so far. And that's what's been funding our employees and our lab work that we're doing right now. We've got our management and legal, all science teams. We've got our 12 business advisors, and we've got 10 employees. And we're targeting companion animal commercialization next year, revenue next year. The other stuff we were talking about for humans takes a little while in the US because we've got that thing called the FDA. And they want to see that, okay, this is going to be safe and all of this other stuff, okay. We want it to be that way too. We can't go into the agricultural animals like cows, pigs, chickens, because the USDA gets involved. They're saying, hey, you're altering the food. We'd like to talk with you about that. But on companion animals, where we're not eating them, it's really not regulated in the same degree as FDA or USDA. So where we went out and interviewed different vet clinics, different vet clinics that were doing stem cell work, and asked if there was a market for doing this type of work, and they determined that yes, there is. There's a lot of work going on in the vet business for rehabilitation of animals, for dogs and cats especially, but even horses. A lot more than we ever thought. And people are paying a lot more than we thought they would to treat, I mean, I bet somebody in here knows a person that spent over $10,000 on the dog. You know, whatever, is there a family member? The same with cats and horses and maybe birds. Looking at that market, we saw that it was huge. We could go into it right away with our product. So that's what we're targeting for our first revenue stream. Well, our second revenue stream. Greg was about to correct me. We have another revenue stream that I'll talk about in a moment. But our first major medical stream, revenue stream, and we'll utilize that to help fund our clinical trials going through the FDA, so we don't have to go out and get so much venture capital, because I think most of you know that that's expensive to get the FDA trials going. But if we have a significant revenue coming from the animal stream, we'll invest some of that in those trials. Don't expect to spend a lot of time on this, but this is based on our data on what the market sizes are currently directly from the people that would be applying it. So, needless to say, it's big. I'm not going to do the thing, well, if we get 2% of this market, we'll get this much. We just know it's big. I think all of you intuitively know that it's big. don't even have to address the human market. It's just big. It's everybody. The animal market, big enough. So where are we with our product pipeline? And we're just about wrapped up here. We do have another product out there through our research of utilizing a lot of stem cells and being able to manipulate them where we wanted. We found a market for some of these manipulated stem cells that we just put out a month ago on our website. We're starting to gain some traction on selling those stem cells, just selling those as a product. So those will be our first revenue stream. Shortly following will be the animal market after we finish up our animal studies, probably sometime this year. So sometime into next year. We've got some logistics to get through, distribution, things like that. If anybody's involved with that kind of stuff and wants to help us and jump on board, please do. And then of course, the one I'm more interested in personally for myself and my family is the human market. Everything we're doing in these other two places is building and supporting that human market. We'll use the data from the animals and the techniques from the cells that we're selling to refine what we're doing in humans. And I keep talking about FDA, and I think many of you probably recognize there's more of a world outside of the US. There's other places that we can and will go with this, and there's places that we could go to tomorrow and not have the regulation hurdles that we'd have in the US. We don't want to do that because we don't want to give this a black eye or a bad name or somebody misusing it. So when we go into animals in the vet clinics, they will also be a revenue stream in that they'll all be certified. We'll regularly be monitoring them. We'll be doing the blood tests on the animals, and then we'll use all of that as a support for how we'll handle the humans as well, so that everything goes smoothly. There isn't much room here for bad consequences, but we still want to minimize and have a good reputation before we go out to the market. Here's some of our management team. 3 of them are here. You may recognize some of these other people. There's a host of other people that aren't actually up here that are on our advisory board, many of them with a huge and broad depth of business experience in biomedical field, etc. But we didn't want to start listing a picture show up here, especially with the time that we had. And now we'll enter into easy questions for me and hard questions for Dr. Atwood phase. And I'm sorry for the abbreviated presentation, but we wanted to stay within the time limit. That's great. I know there's probably questions. Yes?
Yeah. This is super interesting. Is the belief that presuming success, the result will be increased longevity or decreased impacts from aging during a life with a similar age?
We like to refer to the latter, that we're going to improve people and animals' health span. Now, as a consequence of being healthier, you'll probably be living longer, but we don't want to market it as a fond of youth kind of scenario because it doesn't really have a good connotation to it.
Right.
We do feel very comfortable saying that we're going to improve your health for whatever lifespan you have.
I guess I'm thinking specifically of sort of the societal ethical question and the economics question, right? If you're going to cause me to live to 150, that has resource strain implications. If you're going to cause me to just not die at 70 and live till 85, A, the treatment arguably pays for itself in the aggregate, right? Because I'm not suffering these expensive, debilitating diseases, right. and B, I'm not necessarily having the same impact on aggregate population. So it sounds like you're saying that's more of the expected result?
Well, we don't know how long.
Okay.
So we're testing this on older animals right now, like old dogs and old rats, to see what impact it has on their lifespans. But we've certainly talked about those impacts, and there's a number of ways to address them. But I would just direct everybody to the history of humanity, where 100 years ago our average lifespan was 35 years, 40 years, or whatever. A lot of that was due to mortality and young children, but it wasn't as usual to see somebody getting past the age of 40. Many of us would have died of tooth infection or a cut, and getting infected before there were antibiotics, or measles, or polio, or measles you still could, apparently. Some people aren't getting vaccinated. But in any respect, we've had to face that throughout our history, especially most recently in the industrial age. So we anticipate that we'll develop ways to address this as well as this eases into the population, including opening a financial planning wing with our profits that address if you're living too long.
Yes.
Bill, with JangoBio, I can see what you're doing with the stem cell, the actual injections and so forth. But what about the sort of the whole aspect of treatment? Are you looking at this where you're also going to be looking into, say, diet, exercise, vitamins? Does that play a role in your business here, or is it specifically directed to the process that you just described?
That's a good question. That's a little bit ahead of our skis for where we are. We're just trying to show the efficacy and safety, not market it on the human side yet as far, but that definitely could be an impact. Where I thought you might be going with that is another aspect of this that's very important that we didn't have time to talk about here. But by rebalancing your hormonal axis in your body, you also make your body more receptive to other medical therapies, surgeries, etc. Because if your hormones are, well, think about it. When we were all at our peak, well, some of you still are, when we were all at our peak health and our peak reproductive age, we healed quickly. I mean, most of us older people remember being able to recover for something rather quickly or something healing rather quickly, and now it takes a lot longer. If we restore the hormonal balance, that aspect of your health returns as well, or at least we anticipate that it does. So if we can get your hormonal balance in place, then you've got a nice foundation for, now let's take care of myself. I've got the foundation of my health taken care of. Yes, sir.
Are you finding thus far in the animal testing you're doing that this essentially works even with animals that have been spayed or neutered?
That's a good question too. I was waiting for that one too. So we're developing, can I call them organoids? Organoids technically. So we're developing a path to restore the hormonal balance in spaded animals without turning them into turning on their reproductivity again. And we'll talk about that in more detail on the 20th or afterwards, but basically creating organoids that can live in other areas of the body. And that we've had some success with that.
So I'm curious, how do you package your product and actually put it in the hands of the user? Who is that user? Do you create clinics that people come into, sort of like an IVF clinic, or how does your product get to the customer?
Possibly a good question. If you want to come on board and help us with that answer later. We're not at the phase of exactly how that will be distributed yet. We have some ideas in talking with some of the clinics that we've been involved with that we would license them, and then we would, they would basically get a license that was subject to our supervision, and that we would also take, give them product. We would supply the product to them, supervise the application of the product, and then get the test results via the blood samples sent to us, so that we would know where the efficacy and monitor for safety as well. So that's just in general. Have we mapped all of it out yet? Not quite, but we're applying for an SBIR phase 2, and they're requiring us to map out some of that stuff, so we're getting our arms around that right now.
So with respect to the nearer term veterinary markets, in that case you'll be going to individual practicing vets?
Yes, exactly. Yeah, we wouldn't look to open our own. So there are a growing number of vet clinics out there that are already doing stem cell treatment, just like humans are getting. They're injecting elbows and backs and whatever, and they're having limited success, like 20-25%. But it's enough that I would do it just on the chance that it would help my dog if she needed that to get that type of treatment. So that's how they're working. So we would expect much nearer 100% efficacy. We'd be able to see objectively the efficacy with the hormone testing to make sure that the blood changes. And then we could observe the dog, whether it or cat or whatever animal, just to see if it got the desired health benefits. So through existing clinics on animals for sure. Yes, sir.
So happily in recent years, across various aspects of the tech industries, we see more discussions in the realm of ethics.
Yes.
We never stop to ask, should we do this thing? And we see that a lot with data and privacy. What are some of the internal ethics discussions that JangoBio is having?
I think Josh touched on one of the major ones. What's the impact of people living longer, if that's what happens, or animals living longer for that matter? So we have discussed that. Other impacts as people bring them up when we give these types of seminars, we go back and we talk about it. But it's still a little bit further out ahead of our skis. I don't think we have a lot of ethical implications of this, because what we're doing is helping to improve somebody's overall health and staving off some of those age-related diseases. Now, there's ramifications of that, certainly, but they aren't ones that we feel we can address, at least at this time. We have to first say, can we do this and can we do it safely? When we get to that point, then we can have another gate where we say, should we do it? For me, I'm going to do it. The rest of you can decide.
Should we offset Alzheimer's or should we not? Should we offset obesity or should we not?
For those that don't know, Dr. Atwood has spent the bulk of his career as a research scientist here at the UW and VA Hospital on Alzheimer's. One of the ways he found the correlation between hormones and Alzheimer's. So, sorry.
On one of those slides, you kind of, you had that breakdown of exactly how it's done.
Yes.
And you said, other
Not
people
exactly, just generally.
you said other people are doing this, except for we're unique in something over here, and you said we're going to go get more onto that. Can you explain why what you guys are doing that's unique, and what are some of your competitors in this type of a marketplace?
Just in general, we are regenerating the specific tissues that we want to reproduce in your body outside. So what a lot of stem cell clinics do now is they just take your raw stem cells, just bricks, let's look at them as bricks. They re-inject them into you, and then hopefully they find where they're supposed to go in your knee and rebuild part of it or all of it. It's a hit or miss because the environment might not be conducive for stem cell growth in there. You might not have the stem cells in the right stage of their expansion or their regeneration. There's a lot of randomness that goes into that. We're taking the randomness out by taking the tissues far enough along that they know, here's what we're going to be when we grow up. We're this. They're at the early stage, but they're not going to go off and create cartilage or bones or anything else. And even if they drifted around the body, they're not going to do anything else. They're there to create this particular hormone producing tissues. And that's the unique aspect that we're doing.
So nobody else is doing this?
Nobody else is doing that in this space.
Okay.
Some are doing that, like CDI, that some of you are familiar with in town, that are looking to make like heart tissue so that you can test drugs on actual heart tissue and avoid going into animals, for example, at least in some of the early phases. Yes, sir.
I have two somewhat different questions. The first is, are you guys under an exclusive license arrangement with WARP? With WARP? To what extent is any of this under? Not at all. Okay. The other question I have for you is kind of springboarding off of what you said. You said, is it safe? And I guess one question I have with this is, given the timelines on which we're looking for a number of the humans, at what point do you feel confident that it is safe? So if, for example, I had an injection of this, I'm 38 now, I think. I've got a 6-month-old, I don't know what day it is. At what point, you wait 10, 15, 20 years to see, has there been some harmful side effect to me as a recipient of it, or what?
We'll be able to see, on the animal model, obviously, but they don't live as long as us, but we'll be able to see through their life cycle, excuse me, was there any deleterious impact of that? Yeah. On humans, again, we're going back to, this has been done for, how many years of stem cell transplants? With 50 or 60 years. There hasn't been any deleterious effect. The only deleterious effect of stem cell treatments is when somebody gets carried away and they try to inject them in your eyeball, and there's, a side effect of you just tore the retina or you just introduced an infection, because people are injecting stem cells everywhere. But these are your cells in your body, so there isn't an opportunity for them to do anything other than what they were there to do. Some people say, well, couldn't they turn cancerous? No more than any other cell, and none of them have over 50 years of doing this. Mostly with the bone marrow transplants with leukemia patients primarily, right? So what we're doing is not new in that respect. What we're doing that's new is we're targeting creating specific tissues. And what we're finding is that the body will only allow so much to grow in that space, either physically or physiologically. The stem cells won't just like take over your body and you'll become a giant gonad. They don't They get self-regulated. I know it's a fun image, isn't it?
We are actually at time.
Oh, sorry.
So our final question is always to the presenter. What can we as a community do for you? How can we help you?
Well, we're always looking for investors to help move this along more quickly. We're limited in getting this to the marketplace only by the amount of funds we have, the size labs we can afford to build, the number of scientists that we can afford to bring on. So we've got enough to keep this moving along at a steady pace. But if we could get more investors on board early, or collaborators, we could get this out into the market much more quickly on either the animals, or get the distribution done more quickly, or build out more lab space more quickly, that kind of stuff.
Well, thank you. Please check in.